liquid that you use to clean toilets, and you mix it with baking soda.
Okay.
You get carbon dioxide.
Oh, damn.
So even that
You
time,
actually did that.
yeah, you can do that. And
So what was the reaction of parents? Like,
the small battery, if you put 2 wires in water, you see the bubbles come from hydrogen,
Yes,
oxygen.
yes.
These things all fascinated me. Yeah. So class 10, 11, 12, I think my interest shifted to physics and mathematics. But before that, it was chemistry. That's the interesting thing. Yeah. For IIT exam, you study physics, mathematics, which I was doing anyway. And I never liked the idea of going and doing any coaching classes. I somehow wanted to study on my own.
on your own, you ended up getting Air 1 in 1987. So like, I'm feeling bad for those coaching guys. When I was coming here, so in car, like I was thinking in my mind, like, sir is famous for rank 1, but he has done some incredible work in physics too. Like in India especially, like people recognize score and ranks more than knowledge.
Yeah, because I feel our education system does not encourage that curiosity and creativity. One of the questions that string theory is trying to understand is how we can describe situations where the quantum mechanics and gravity have to be kind of married together. Quantum mechanics is behind everything that we use in modern technology. They say even like 50% of the US GDP is perhaps based on quantum mechanics, whether it's our laptop or the cell phone or the digital camera in the cell phone, whether it's the lasers that are used in our surgeries or anything else. Lasers are used in so many things, or whether it is GPS or atomic clocks, which have atomic clocks, or MRI machines where we do our brain scan or any other things. Everything uses the laws of quantum mechanics.
Okay.
If these laws of quantum mechanics had not been discovered, we would not have had semiconductor chips, we would not have had anything.
Okay, and so like you spent 13 years in HRI.
Yeah, vanvas, I used to say.
Vanvas.
Because I was living in the jungle. It was a nice vanvas.
So hello everyone, today we are at this beautiful campus of ICTS and we have Professor Rajesh Gopakumar with us. He is one of the most brilliant minds of India and one of the most renowned physicists of India. Swagat hai, sir.
Thank you.
It's a pleasure to have you on my channel. So to begin with, I would love to know about your early childhood, any vivid memories from your early childhood days.
So my childhood was spent largely in Kolkata. My father was in the Indian government service in the ordnance factories, and he was posted largely in Kolkata. So I remember, I have very vivid memories of Kolkata. It was a very in the 70s, 1970s and early 80s. It was quite a poor city, but it was very rich intellectually. You could see that it was a city that gave a lot of respect to culture, to thinking, to science. The colleges and the culture of reading was very much there. So there were small libraries where I used to go and borrow books and read. Of course, it was books were very expensive, so only occasionally you could buy something. But there were many second-hand bookshops on the pavement. There would be many books which you could buy at a reasonable cost. So that way, Kolkata, there are some famous streets, College Street, where the Presidency College and others were. That used to have a lot of physics, maths, textbooks. Then there was another place called Free School Street, which used to have a lot of fiction and other general books. And I used to go to both of these and just find some hidden gems. That was, you should remember, that is a time before internet and anything else. So knowledge was very precious. Wherever you could find it, you tried to grab it. There were some small encyclopedia once my mother had, parents had brought, I think, for me. These were all very precious things. I also have vivid childhood memories of spending in my grandmother's house in Kerala. So I'm originally from Kerala, and my my grandparents were in Trivandrum, Thiruvananthapuram, and my mother's mother, maternal grandmother's house was a very nice place at that time. Trivandrum, even though it was a city, still had a lot of greenery, and there were many fields, and there was rice fields and coconut plantation, and my grandmother had some land which was just next to a small river, so coming from a big city like Kolkata to this was also it's something I used to look forward to, and going and playing in the kind of field there, and seeing many animals. There used to be snakes, there used to be many things, so that was a different kind of life which I used to also like. I used to like, I think my first interest was in making things. Like I used to make with little boxes and all. I used to build some elaborate cities and railway lines. I used to be fascinated by trains and train journeys. Once my father had gone to Russia for some trip and got back a train set, which was a precious belonging, which I still have actually, with very nice engines. And so these were some of my childhood memories, maybe till class 7 or 8, some of the very precious ones.
So you were a very curious child, like you were curious about many things, as you mentioned, about books, about things and everything. The reason why I asked this question is, like, I met many of scientists, and most of them got the clarity very early in their life, like, their interest towards academia. So that's why I asked this question, like, how was your childhood?
Yeah, no, I definitely was very hungry for getting to know things, understand things, and at that time books were the main medium to learn things and understand things. So I used to use that, but otherwise also I used to be I used to have a certain curiosity about things. And for 2 years, actually, I spent in classes 7 and 8, I spent in Trivandrum, and that school also had a big campus which had a lot of jungle, this, that, so I used to like exploring those things. And there were a few friends there who were also very interested in science, so we used to discuss, and some other friends afterwards in Kolkata also with whom we used to discuss mathematics. Little later, maybe. I used to have a small chemistry set. At that time, again, it was difficult to get chemicals, but I used to be fascinated by all the chemical reactions. So if you just take like the liquid that you use to clean toilets and you mix it with baking soda, you get carbon dioxide.
Oh,
so even that
you
time,
actually did that?
Yeah, you can do that. And
so what was the reaction of parents?
And so I used to try not to show them. And then there was also, with a small battery, if you put 2 wires in water, you see the bubbles come from hydrogen, oxygen. Yes. These things all fascinated me. Yeah. So in a way, my interest sort of came through chemistry in some ways too. I used to like chemistry and I used to like mathematics.
I read somewhere that you used to like physics and mathematics, and chemistry used to bother you.
That came later. Okay. So initially, when I was in classes 6, 7, and 8, I used to like chemistry a lot because it was like this fun to do some experiments and this thing. And it is through chemistry that then I learned about atoms, and that fascinated me, that how everything, all these chemical reactions basically happen because there are are just a few atoms in the universe, few different 92 kinds of atoms, the stable ones, and from that you form all these compounds. So that was very fascinating to me, that aspect of chemistry. And through that I learned about quantum mechanics, because why are there so many atoms? What is the structure of the atom? So that's how I got interested in physics. And then, so this I'm now talking of class 9 or 10.
In class 9th and 10th, you got this much of exposure.
Yeah, so I used to get some, so I liked maths, and then I used to be interested in this. But then the chemistry became too much of, you had to memorize so many equations. Then I found it very, so class 11 and 12, the chemistry, by then I think I had kind of lost interest in chemistry, and I used to find it a little difficult to just keep in mind all the different kinds of organic chemistry, inorganic chemistry, other things. So then I think my things got so class 10, 11, 12, I think my interest shifted to physics and mathematics. But before that it was chemistry. That's the interesting thing. Yeah.
But sir, incredible childhood. Like when I was growing up in Rajasthan, so we got exposure of these government jobs, like not much about science. So we are like brought up that way. And like your childhood is like dope. So then when how did you IIT came into the frame? Like you prepared for IIT?
I was interested in doing physics or mathematics, so I was thinking of studying in a college. But one of my seniors who had gone to IIT Kanpur, so when I was in class 11, so I didn't take any coaching classes or anything because I didn't want to. I was not sure I would go to IIT. In fact, I thought IIT is for engineering, so I didn't really think about it. But I was studying physics and maths on my own, and but then one senior of mine told me about how was actually my neighbor and gone to 1 year senior to me, and he had gone to study engineering in IIT Kanpur, and he told me about the wonderful physics department there and how some very good teachers were teaching them physics courses. So that interested me, and so I started considering IIT Kanpur as a kind of goal. And of course, for IIT exam, you study physics, mathematics, which I was doing anyway. And I never liked the idea of going and doing any coaching classes. I somehow wanted to study on my own and find my own way. So then there was one at that time, something called Brilliant Tutorials, and they had a YG file, a kind of a question bank, which I took mainly for the chemistry questions. So that is what I used for some months before the IIT to make sure my chemistry was also okay. And, so I managed, I think, somehow with the chemistry.
On your own, you ended up getting year 1 in 1987. So like, I'm feeling bad for those coaching guys.
But Brilliant Tutorials used my name because I had taken that YG file.
Oh, okay.
Because it's more a question bank. It was not a class, but okay, they were. So they advertised that a lot. But Agarwal classes, that was the other big thing that everyone used to take. That I didn't take. So one thing I'm slightly proud of was later, I think in 1990 or something, they had run these big glossy advertisements on the front page or back page of India Today and these big magazines, and it said like toppers almost always come from Agarwal classes, because there was one missing. So I felt very proud that they couldn't say always.
Yes.
But anyway, those are childish things. But anyway, I think if you know what you're interested in, I think coaching classes, maybe they try, I don't know their philosophy, but I feel one has to understand something conceptually. That is the strongest form of understanding, and that in a way is up to you. It's your responsibility. You have to put in that work and understand the thing in a deep way. Without that, you may learn how to solve some problems quickly, but it's not real understanding. So maybe my way helped me, but that's all I can say.
But sir, rank one is a big part of your life. Like you're still famous for rank one.
Yeah, it is a
Apart
little
from-
funny because my identity is more as a physicist and a
Exactly.
theoretical physicist, but people always remember that. I guess in the general public, that is something everyone can identify or kind of recognize. But in the end, for research, that doesn't matter at all.
Exactly. When I was coming here, so in car, like I was thinking in my mind, like, sir is famous for rank one, but he has done some incredible work in physics too. Like in India, especially, like people recognize score and ranks more than knowledge. So this is the case in India. And talking about today's time, about coachings and all, the way ranks are celebrated, like it has become a whole business. So if you can say
Yeah.
anything on that.
Yeah, because I feel our education system does not encourage that curiosity and creativity. I mean, you're supposed to, yeah, for getting a high score, you have to just try to you're doing some questions someone else has set and trying to do it as fast as possible. It's like running a race. But creativity is a different thing. It's not something you will do in 90 seconds. You have to tick some multiple choice answer. And for that, many times nowadays I see the IIT exams, it's completely multiple choice, in which case, okay, you can eliminate things. You don't have to understand things fully to know what the answer is. You just have to get it. Or you may make you may have a good understanding, but you make a careless mistake and it's nothing. So that kind of short-term run-in sprint like thing does not identify people who have creativity, because creativity often requires longer thinking. Someone who has thought about something for a long time and then something emerges slowly. That kind of thinking is what is behind the biggest scientific breakthroughs, which our system, unfortunately, as of now, doesn't really encourage or cultivate. So that is a problem, I feel, and that's why maybe we can do better in being innovative, I think, in science at least. We should, given a country of our size, I'm sure there are many curious children, many curious future scientists, but they get maybe channeled into these classes, and that kind of kills their creativity or their, because everyone says no, don't bother to ask those questions, you just do, this is in the syllabus, you do this, you'll get your marks, you'll get your score or rank or whatever, and bas utna hi chahiye. So then people get pushed from thinking those things, because every child is curious. I mean, they always have questions, but the schools have to nurture that curiosity or expose them to new ways of thinking, different things, and show how exciting it is. I mean, yeah, it's a challenge.
So exactly. Sometimes I also think like coaching corrupt minds. Like, when I see students are preparing from class 6th nowadays for JEE, like it is just an exam, and like, you should give that much freedom to your mind to learn new things.
And explore things, and kind of, in a way, you have to wander. I mean, the childhood is very important to wander around and kind of just pick up things differently. If you regiment children and they're studying from morning 6 o'clock, they're going to a coaching class. After they come back from school, again they're going. I hear at least people, or they go to places like Kota and stay there whole day. They're just with this. Yeah, I think it kind of deadens the mind.
Okay. But talking about you, so after getting rank one, so the decision that you make, like I was wondering, like, how did that guy choose physics over CS? Like at your time, I think during late 80s and early 90s, IT boom was coming in India.
Yeah.
So why physics? Like people must have questioned you, like parents, कि why physics over CS or engineering? So how did you tackle them?
No, I just said the rank. Okay, rank was not in my control. I want to study physics. That's why I gave the exam. Whatever rank, if I could get physics, I would have taken physics. So ये रैंक भी मिल गया तो फिजिक्स लेना था, फिजिक्स ही ले लिया और बस उतना ही है मतलब then I mean my parents were very supportive. They were also a little bit surprised. Many people said, oh, physics if you take you'll maybe just become a teacher or this thing. I said that's fine. I just want. I love physics and mathematics. If I have to teach, that's also okay. क्या उसमें क्या खराब है this thing. So yeah. So I mean, computer science was interesting. It is a little mathematical. But I was more interested in physics and maths. That interface, the connections between mathematics as a language for nature, for understanding nature and physics. So that was my interest, and so my first choice was either physics or mathematics in Kanpur.
Okay.
But then I decided to do physics because, but still, even now my interests are in both subjects.
So you're excited about doing research in physics or about being a teacher in physics?
I wanted to do research, but I think I didn't know at that time. You don't know whether you can do research or what will happen. But I thought, okay, even if I cannot do research, I will at least be able to communicate the interest of physics to others. That at least that I can do, even if I am not able to do any profound research. So that is so for me it was okay. I wanted to do research, but and I was driven to do research. But at that age, you don't know what it takes or.
So during our time at campus, like what used to fascinate us was like life of professors. So when we used to look at like from our perspective, okay, professor की life काफी chill होती है. They work in their own hours. They do research when they want to. They work when they want to. So we didn't look from the other angle like research, but we looked from a career
outside.
perspective.
Yeah,
It's a very chill life after certain struggle.
It depends on the individual, I think. Everyone reacts in different ways. I think it is I think the one positive thing is that you are very flexible. Things are very flexible for you. But the opposite side of the coin is that it is also you have to be self-driven. So if you're self-driven, you can spend 16 hours a day, 18 hours a day working because it is coming from inside you. You're motivated to this thing. So, and that's how I think the best research comes. If you are self-driven and you will do it, of course you need to take breaks and but what I'm trying to say is that the responsibility falls on you. And some people, of course, if they have the option to chill, they will do that. But some people will be driven for their whole life because they get a kind of, that is their, in a sense, reason for their existence. That is the main thing that really drives them. So in fact, if you're so even now I mean I'm from 7 to 11, 7 in the morning to 11 in the night, I'm still thinking about, of course I have many other duties and responsibilities, but all my waking hours I'm still intellectually processing things, and that comes from some inner drive. And I think ideally the scientific profession should be a self-selecting one in which those who have that inner drive should pursue science and should be given the support and the opportunity to do science, because it is from such things that new ideas will come, new things will come. So what we need in our country are more such self-driven people who for whom science is a passion. That I think is what we need to create. It is not guaranteed that with hard work, new ideas or creative ideas will come. You can spend years banging your head and it may not come, which can be very frustrating, and which is why one has to be very careful of one's mental health in something like this, because you can be struggling with the problem day after day, not succeeding, not making progress, or something else happen. I mean, or if you're working in a lab, many things go wrong. Many things can happen. So you have to have a lot of resilience also for that. So those qualities, if you have, then enough people in a scientific ecosystem have that, then good things come out. That's my experience from seeing many scientific communities I've seen around the world, all the successful communities, successful scientists, and I think that is very necessary.
So exactly, like sometimes I also think, like as a scientist, if you are researching on some problem, so there is a high possibility like you're working 2-3 years on that problem and you didn't get any result.
Yeah.
So it needs that much of patience and dedication.
Yeah.
So I think only self-driven people should go into these kind of fields.
Yeah, I also feel it's, but it is difficult to know that at an early age. So you have to, those who have curiosity, interest, should pursue it, and later they don't have to become academics. They can become science you can study and do many other things also very fruitfully, because the training in physics that you get in a BS program or something in IIT Kanpur, you come out of that, you get a very broad training, because physics, when you learn it at the undergraduate level or even at the PhD level more, you are trained to think in a very logical way. You're trained how to model complex systems. You're trained how to analyze a problem by breaking it up into smaller solvable pieces. This training is very valuable for tackling many problems in life, society, everything, whether or in an industry or so. That's why, especially in the US and other places, but I think beginning in India also, people are valuing students who have gone through that training. And if you have gone through a PhD, even more, because there you are really taught how to pose questions and try to answer them, pose the right questions, the ones that you can make progress on. You learn that quality. So I think even if you do not become an academic, physics training, if that appeals to you, is a very good thing to have. And you can do other things with it afterwards.
And sir, how UG at IIT has shaped your mind? Like, although I'm very interested in parts other than academia, like I got to know that you are a very brilliant athlete at IIT.
No, I'm not. I don't know, that was somehow that story has come. I'm not a brilliant athlete at all.
So you're not a powerlifter?
No. I think somewhere this wrong story came. I used to participate in a lot of the cultural events in IIT, like Culfest, and I used to represent IIT in some of the quiz various in the festivals in IIT Delhi or various other colleges. I used to go with some teammates. Also some of the, many of the cultural events in Kanpur and elsewhere, I used to be very this thing. But I was never a very good sports person for some reason.
So you didn't play sports at all?
I mean, nothing in any big way, nothing seriously that I was there. So somehow this...
My bad.
No, I know it is there somewhere. I've seen someone else also had told me about this. I clarified that it is this thing. But I used to do, I mean, I think a lot of my formative period was not only academic, it is just the setting of Kanpur IIT and my colleagues, my fellow students, and that played a very formative role, I think, because very close friendships you build, and And IIT Kanpur is unique because it's like a at least it was in my time. Now it has maybe changed. You used to live only in the campus. We hardly used to go out anywhere in the city. So it was like being in a little isolated place, and you could, I don't know, you could go very deep into things. Where you could, I liked the walking outside near that canal, and you could, you had, at that time, there were even many places on campus which were empty. Now there are many buildings, hostels. So you could go inside the campus for a walk near the airstrip, many places. The nursery I used to like. So the campus had a very unique feeling to it, and the setting I liked very much. Which is what later also in a way influenced my moving to Allahabad. I spent 13 years later in Allahabad at a research institute.
After US.
After the US, yeah. So because I liked that somehow in Uttar Pradesh, the kind of empty, vast spaces of the fields and so on. Kanpur, otherwise, yeah, the teachers were also fantastic, many very good teachers, and that was another very different thing, I think, compared to other places in the world, that the teachers would take a personal attention for you. They would really want you to grow, and it was like a very guru shishya type of it felt that personal attention was there.
Now it has changed a lot.
Now it has maybe changed, and that first generation of teachers who were there, most of them had come in the 1960s after doing very good PhDs and so on, and they wanted to make, they had a lot of idealism to make a different kind of teach and communicate concepts and train people, and I think many of them, they did a wonderful job, and they were such good human beings. You could go to their houses, you could chat with them, have chai and talk for long hours, so that feeling I really cherished.
So actually, when I met Professor V. Rajaraman, last time I came to Bangalore, so he told me like, a student used to come to our home and say to my wife, dosa banao, khana banao. So that was the bond, ki they go to know each other, there was a bond.
Right.
And now it has evolved a lot, it's more of a kind of interaction thing.
It's much more professional.
Much
also
more professional.
It's much bigger. Like our batch was still small, like how many, 280 people in our whole year, incoming batch. And it was like that. That was still reasonably big, but yeah. So, but now there are, I don't know, 1,000 plus people coming every year.
1137 were in my batch.
Yeah. So near 3-4 times. So that's a big. That's a big factor. So then it becomes difficult also to have that kind of interaction.
But when you became a professor, so how you used to look into things like as compared to your time when you were a student and then you became a professor?
So when I was in Allahabad, which is where I think I first took on a faculty position, it was also a small institute. So we had only a small number of students. So again, there was a much more informal feeling there, and it was kind of similar in a way. I think that's why I was also attracted to it. It was even smaller than IIT Kanpur. There were maybe 30 faculty and maybe about 100 students, 120 students, something like that. So PhD students only, and so it's a small, and it was a campus. Everyone used to live there. So many students used to come home. My wife would organize some music sessions. People would just sing different things. It will go on till midnight. So you had that same kind of informal thing. feeling was there, and even Professor Ashok Sen was in the same institute. He was our neighbor also, and he used to organize pizza parties and make pizza for all the students and others in our group, at least in the string group. There used to be this barbecue parties, and I mean, so it had that feeling was there. So I felt in Allahabad we had a little bit of that same sense.
You have made so much of unconventional decisions in your life, like starting from choosing physics, then coming to Allahabad after US, like which we don't see in many cases. So like so after IIT you went to US, right?
Yeah.
To Princeton.
Yes.
And you ended up doing a PhD under David Gross. So
Yes.
how did that happen? Like, how did you landed up there?
Yeah, I mean, I applied to 3 or 4 US universities, I think. I didn't hear back from one, but I had offers from Princeton, MIT, and Caltech.
Okay.
And many people whom I had known suggested I go to Princeton, and specifically mentioned David Gross as a very wonderful mentor, as a very wonderful teacher, physicist, mentor. So though MIT was offering some bigger scholarship and everything, I decided Princeton I will go. And of course Princeton also has, Einstein, that Institute for Advanced Studies, so a certain aura was there about Princeton also. So I chose to go there, and it was very good. I think the decision to work with Gross and the fact that he accepted me as a student was, I think, a very important one for my life, because he's still very much a part of my life even now, because he is still the chair of our advisory board of ICTS. And so in fact, only day before yesterday I was having a call with him, talking to him. He's still very interested in India and Indian science, and he has helped a lot, I think, even from the formation of ICTS. So I think David Gross, working with him was a very unique experience, and he's very well known for having mentored some very brilliant students also. Edward Witten and Frank Wilczek were among his first students. So I think he's the only person whose students have got, one student got a Nobel Prize and one student got a Fields Medal. Okay. so that's the only I think.
Is there any pressure on you?
So once I was saying, that was a tough act to follow.
To keep that legacy.
So anyway, and of course he himself, with Frank Wilczek, he got the Nobel Prize for his discovery of this fundamentally the strong interactions, and so that work was in the 1970s, which was still now, it's one of the cornerstones of our understanding of the forces of nature.
But he got Nobel in 2004, I guess.
Yeah, okay. Right. So any case, so that was much after. I was a student from 1992 to 97. So at that time he had not got the Nobel Prize or anything. But anyway, he was clearly a great mentor and a very strong presence in the physics department at Princeton. And again, there were many good classmates. I enjoyed that. I think I learned a lot from some of my very brilliant classmates. You saw people from all over the world come there, so that was a unique experience.
But by Nobel, I remembered a very funny incident. So when last time I came to Bangalore, so in morning I met Sienna Rao, and then in evening I met V. Rajaraman. So V. Rajaraman said, how is Sienna Rao? I said, okay, sir. So he said, he must be upset. I asked, why, sir? So this year Nobel Prize is won by a computer scientist. So I was like, keen AI, so right. I was like, sir, that was too funny. But any opinions on this? How AI is revolutionizing the research and everything?
Yeah, no, definitely. I think this year was special because chemistry and physics both had people with AI they were recognized for their AI contributions. I think I would say we are at a stage where a lot of interesting developments have happened, but we are probably now, it's only the beginning. I would say it is the end of phase 1, and we are at the beginning of phase 2, where it will take on, I think, an even more different, it will evolve in a different way. Maybe all the developments of the last 60, 70 years which have led to this particular ChatGPT and other things, I think that maybe we are kind of reaching the end of that. But I think we need now some more new ideas to take things to a different level. That is from the point of view of the fundamental AI question about how you can have better and better AI systems. But even with what we have right now, I think it is changing science a lot. I think it is augmenting the capacity of scientists to do things that they could not do earlier. I think it will be like an assistant. It will be a very strong, powerful assistant for science, which will enable you to do more things, do things faster. And science always has had that evolution. I mean, Newton and all the old scientists, they used to calculate by hand, do long numerical arithmetic by hand, very long calculations, various famous mathematicians also. Then, of course, with calculators, that was unnecessary. With more and more computers, that also became faster. Even mathematical manipulations like what we are tested for in JEE, doing some integrals, those also you can do now in Mathematica. I mean, you could do 20 years ago in Mathematica or some symbolic manipulation packages. So those skills are not the important skills. Those the computer can do. And now with AI, there'll be similar things. AI will do certain things. I think the scientists, that's where it will become more important for scientists as human beings to come up with the genuinely new ideas or questions. Because AI, I don't know whether at the moment, whether it has the ability to ask truly interesting new questions. It is the framing of the right question which is often the important thing in science, and choosing that, addressing a certain thing from a certain point of view. And that is usually not a deterministic process. It's a process of imagination and thinking. So I feel human beings will have to focus more on that aspect. So that's why creativity is more important. We were going back to our earlier discussion about encouraging people. You make them do some algebra fast, or make them do some integrals in 90 seconds. That's not going to, the computer will do it. Why are you making these kids do that and testing them on that? Test them on how they can ask a question that a computer can't do. So that is what I think we have to think of in the future. And science will be like that. There will be these AI assistants which will help in doing things.
So do you think like it could be creative someday, like, and think like humans?
It's difficult to say. I mean, it's probably premature to say that it cannot be. I don't think the current development, it is still there yet. So as I said, maybe one phase has ended. Now maybe you are going to a second phase. Maybe in that phase it will enhance its abilities in a different direction, be able to generate these imagination, thought, like humans can do, fantasize about things, speculate about things. In a kind of non-linear way. Yeah, it may be possible. We will need some more breakthroughs to do that.
So we drive our assumptions from movies, sci-fi movies we see, and we're like, okay, this will happen someday.
Yeah, it can. I mean, it may well. I mean, I don't see any fundamental obstacle in it happening. That there's nothing in principle, I feel, that prevents these machines from having similar thinking. We don't still understand our own thinking. Neuroscience, I think, we still don't understand how concepts are formed. They change in our mind. So if that kind of architecture, at least the abstract structure of our thinking, if that can be modeled on a computer, yeah, it can also probably do the same thing, but it may come out purely by chance, by accident. Like, in a way, modern AI has also come out in a sense by accident. People don't really understand why it works so well, just having several depths of neural networks. So it remains to be seen.
Sir, coming to your field, like you have talked about your time at US, but how did you decided your problems to work on? Like, how did you decided the domain? Like, okay, I will work on this problem, or like.
Yeah, so I was, I think my thinking was just guided by a sense of what I found beautiful and elegant, and trying to find the topics where the laws of nature are very are fundamentally kind of trying to fit together things that we don't understand very well. Like in physics, there are still basic questions we don't understand, and I think my own intuition is sort of, I like that interface between how mathematics and physics interact, and how mathematics can guide your thinking about physics, and try to answer deep questions of physics. So I find that very fascinating. How is it that this mathematics can capture so much about nature? And I feel it always has a lesson to tell you. It always kind of takes you by the hand and shows you which way to go. So I've tried to follow that kind of intuition. But broadly speaking, the areas of understanding the fundamental forces of nature, whether it's gravity at the quantum level or some of the other strong interactions, I think these have always attracted me as very powerful. They're very basic questions, and they tell you, I think they're giving you hints about some new structures which we are still uncovering. So I like solving puzzles, crossword puzzles or jigsaw puzzles or something, like where you have to assemble many things and then see how they fit. So it's a bit like that. You're trying to figure out, nature has given you some clues and you know little pieces, but then from that you're trying to fit other things and form a larger picture. Then suddenly the whole picture has to come out at you. So you know only little pieces and how. So that fascinates me, that kind of aspect of puzzling over things.
Okay, so like then I started working on this string theory and all. Yeah,
so that's in a way the reason I started doing things in string theory. String theory, and even now at what is called quantum field theory, sort of work on the interface between the two of them. To try to understand in a way what is string theory. String theory is a theory which we still don't understand. It's a kind of, it's again a puzzle.
Sir, can you explain it for a layperson like me? Like, what exactly it is like? Otherwise it will go bounce.
Yeah. So let me put it this way, that we have so one of the questions that string theory is trying to understand is how we can describe situations where the quantum mechanics and gravity have to be kind of married together. So normally gravity, we have a good understanding. We learn about Newton's laws, then later you learn about Einstein refined those and in fact changed the whole framework of understanding gravity in terms of space and time, or geometry of space and time. But that is still, so to say, at the classical level, meaning it is, but it is not taking into account the fact that the underlying framework we now understand of reality is based on quantum mechanics. So quantum mechanics was of course discovered in trying to understand the atomic structure, but it is it is the broad framework with which we understand all of reality, all of physical reality. It is what governs everything from atoms to stars and galaxies. Of course, you don't see the quantum effects very easily in, say, our everyday life because of various reasons, and that's why initially people did describe things in terms of Newton's law of gravity and other things. But we know that, say, inside a black hole, which forms when stars collapse, we must have quantum effects, must be there together with the gravity that has led it to collapse. And the space and time there have a very different geometry from what we are used to. So to describe that geometry in quantum terms is one of the big challenges for theoretical physics. It is also very important if we are trying to understand the Big Bang from which we believe the universe evolved. So there also, the very earliest times, at the time of the Big Bang and shortly after, quantum effects were very important. And in fact, they lead to all the, at some level, it is quite remarkable. Those quantum effects are why we have the different galaxies or clusters of galaxies. They have come, initially everything was very uniform, but how did things separate into different separate entities, different galaxies or different clusters of galaxies? That came because the quantum effects gave little bit of inhomogeneity, little bit of structure, which led to, together with gravity, then led to the formation of galaxies and clusters of galaxies. So quantum effects were very important in the very early universe also, to be able to generate what the kind of universe that we see now. But precisely, again, how to do that is something that we don't fully understand. So this question of what is called quantum gravity is one of the big things that string theory tries to address. And it tries to address by a framework which is still evolving, I would say. It has something to do with at least one way in which people thought of it, which is only, I think, partly the full picture, is to think of string-like excitations, like a rubber band. A rubber band is like a string, and it can wiggle around, it can oscillate, and some of the modes of the oscillation of the string can describe the forces very much like gravity, and it can describe other forces. So that was one reason people started taking seriously the idea of a string-like object. But I think you can, that is only part of the picture, and a string-like object actually is a natural thing to consider in many respects. So that's how the subject has evolved. So I don't know if the answer has been too complicated, but it is basically, string theory is trying to understand gravity with all its quantum effects, which we still don't understand, and which is necessary for understanding really black holes or the Big Bang or many other such extreme situations that we have in the universe. And in the process, actually, you may learn things about other quantum systems also in the real world, which is why many ideas are now being used for quantum information, using ideas of quantum information, and quantum gravity ideas are playing a role in quantum information also. So it's a very interesting set of connections between different ideas. But it is a jigsaw puzzle for which we have only a few pieces. I think until the full picture emerges, we will not have it will be a little piecemeal. So maybe I can give you a better answer when we really see the whole picture.
No, sir, you explained it very nicely. But sir, any practical implications like in real world, like of string theory or quantum mechanics? Like people often say, okay, this sounds very cool, but what is the practical application or implication?
So string theory, it remains to be seen. But quantum mechanics, actually people don't realize that quantum mechanics is behind everything that we use in modern technology. They say even like 50% of the US GDP is perhaps based on quantum mechanics, whether it's our laptop or the cell phone or the digital camera in the cell phone, whether it's the lasers that are used in our surgeries or anything else. Lasers are used in so many things, or whether it is GPS or atomic clocks, which have atomic clocks, or MRI machines where we do our brain scan or any other things. Everything uses the laws of quantum mechanics. If these laws of quantum mechanics had not been discovered, we would not have had semiconductor chips, we would not have had anything. It would have been like life before 1925. It would have been frozen there. We would have had electricity and these things. That is still something we understand pre-quantum mechanics. But anything beyond the technological developments, beyond 1925, what we have had, we would not have had. Because 1925 was the year the real laws of quantum mechanics were discovered, which is what enabled most of the technological breakthroughs since then. So we wouldn't have had computers, we wouldn't have had digital cameras, we would have had those old box cameras where you put a photographic film plate and try to this thing, or even these cameras.
You doing this shoot.
Yeah, and then the internet, optical fibers, which carry all these. A lot of these things have based on
laws of quantum mechanics.
Yeah.
Okay. Sir, so after Princeton, you went to Harvard for your postdoc. So tell us about that tenure.
It was a little quite different from my Princeton years. Princeton is a small town. It is a little isolated that way. And of course, there is a train and you can go to New York City, which is like Bombay or something very lively. That was 1 hour, 1.5 hours away. So but you can't, it's not, you go once in a while. So I liked that because I used to miss, having grown up in India, I used to miss the crowd, a lot of people. So, that way going to Harvard was very nice because it's in this town, Cambridge, which is just across from Boston. It's very lively, a lot of people, you can walk on the streets and go anywhere you want. There is public transport. So it's not just the university. There's a whole life around you. And so I enjoyed that very much. I used to live near Harvard Square, and it's very lively with bookshops and theaters and restaurants, and everything was there within walking distance. And I had many good friends also there. Not just from my physics connections, but other connections also. So in a way, that was much more personally very much more enriching. I think physics-wise, of course, Princeton was very good, but it was a little isolated. But these years in Boston, they were very enriching and very fulfilling. Also, your postdoctoral years are where you go from being a PhD student, where you have an advisor, and your advisor is generally mentoring you and guiding you. As a postdoc, you become more independent. You kind of start thinking on your own about questions. You get a sense for which questions you can tackle, and so I enjoyed that. And I think there were a couple of the senior professors at Harvard in the string theory group, Andy Strominger and Kamran Wafa, both of whom I collaborated with, and it was great to work with them and do various things. And you felt you were working on a more equal terms with people, because you were not just a student. So that independence and confidence comes when you're a postdoc, I think, and that's important. And you start mentoring other younger students, which I did. So those were very formative years that way, and I spent 4 years there. In between, for 6 months, I was also at Santa Barbara for a very good workshop. So those years were very fulfilling.
So the crazy part comes after Harvard, like when you came back to India. Like with your credentials, you could have got job in any of the universities in US, I think, and then you came back to India. So thankful to you. Like एक इंडिया से जो ब्रेन ड्रेन होता था पहले कि जो लोग यूएस जाते थे वापस कभी नहीं आए, and then you came back to India. So like what was going on in your mind? Like
I honestly felt, I mean, I even before I went, I knew I would be coming back.
Okay.
Before I went to Princeton, I knew I would be coming back, because of course, at that time I didn't know the US. It was just my thought. But because I always wanted to come back and do something good, constructive.
Come back for like...
Just, I felt IITs have done so much for me. I mean, that time IIT, we used to pay fees of 20 rupees or something. So the government of this poor country was subsidizing someone like me for my education. I felt I should do something in return. So that was always there. But also when I went to the US, I enjoyed the physics, and I made new friends, and I still go back and visit and spend time there. And there is a very good intellectual climate. But I felt I had taken very many good things from there, and now it was I didn't want to spend the rest of my life in that place where, if I join some university, I will be one more cog in some big machine. Everything is more or less well set there. Things are established. They have a tradition, and things go on, and it's a kind of there's a set trajectory. Whereas in India, things were changing, and this was also, you should remember, I went to the US in 1992. That was the year the economic liberalization happened. And then 97, I finished my PhD. 2001 was when I was returning back to India. So many changes had happened in India. I used to come back every year and see how things are changing. And I could see there's a lot of new energy was there, and a lot of things, a lot of rapid changes were happening, and I felt, this is the time you can actually do some things, shape some new things. So that idea of maybe shaping a new institution and making a substantial difference in a place where you didn't have such strong institutions, or didn't have so many very high quality centers of excellence which could be role models, that I felt was very important. And so that thinking was always there, that in addition to my research, I should be doing something kind of with a bigger goal.
But sir, like the ease of life that you had in US and coming to India to Allahabad, which is still not too developed. Like
My needs are simple. I don't have any fancy needs or anything. I mean, so and people don't appreciate what is really important in life. I mean, one has to think a bit. I mean, is it that okay, you have a lot of money and you can buy whatever you want or do some things? Maybe for some people that's important, but for me, the years I spent in that Harishchandra Research Institute in Allahabad were very valuable, very precious. I don't think any money could have gotten that kind of quality of life. It's a very different quality of life. It's an intangible thing. It cannot be measured in terms of money or anything. It's the sense of being in a place with nature, with the Ganga was next to our campus. It used to flow, and the Sangam was 2 kilometers away. You could see, I could go on walks by the Ganga, walk all the way to the Sangam, and there was the Kumbh Mela, Magh Mela, these things, and you saw different things, and I still miss the Ganga Ji, so to say, that having that river and it's big, this thing next to you, it's a presence. It's a different thing. It affects your mind and it affects your consciousness. These are things that you can't get with some big salary in the US. It's so, and then Harishchandra Research Institute was also a new institute. It was just building up, and Professor Ashok Sen was there, which was
there when you joined.
When I joined, he had already moved there, and so the string theory there, it was a chance to grow. Also, in my area in string theory and theoretical physics generally, we don't need that much resources for our. We need some for our, of course, some to maintain contacts. You need to travel and have visitors come to your place, and you go into places. But otherwise, it's not like you need expensive lab equipment or anything like that. And India has the tradition of doing well in string theory. People like Ashok and Spenta Vadia and many others had come back to India and built many centers of excellence. So HRI was a new place. I think it was growing in string theory, other areas. I think I had moved to HRI just at the time when its new campus had been built. So I liked, as I said earlier, I liked that. I liked Uttar Pradesh, that mahal of being in a very different open atmosphere of course, the roads in Allahabad were bad, the medical facilities, and even for most of the years I spent there was hardly any air connection even. Sometimes there would be a flight, but then I liked train journeys, so it's fine. I used to travel by train. So all that was there, but it's less important. So it's a matter of priorities, what you think is more important in life and less important. Different people have different orderings. So for me, Allahabad worked very well, and Harishchandra Research Institute in particular, HRI in particular.
Nature also helps you to think better.
I think exactly. Our campus had a lot of woods and trees with so many different kinds of birds, and this place beside the Ganga where you could just sit and just watch the river for hours. You can just sit there and just watch. Exactly. It helps you think. It clarifies your thinking.
Sir, are you a very spiritual person or something like that?
at some deep level, everyone is. I think. I mean, of course, understanding nature is a spiritual quest at some level. I think as a physics, and you're trying to understand the universe, it is kind of at some level, like Einstein and others said, is something. It's a spiritual quest at some level, yeah.
And like I have read, like many physicists have been like very spiritual, like even if I recently saw a movie Oppenheimer, and in that also like Oppenheimer एक गीता के श्लोक से काफी प्रभावित थे, and so are you very spiritual, like in that sense?
I mean, I like philosophy. I like thinking about the cosmic questions, questions or transcendental
when you
questions.
think about cosmos, like how everything is sequenced and like put into place. So like when you think from other perspective, like like nothing can exist from nothing, so there should be something in the beginning. So I'm talking from that perspective.
Yeah. So the thing about physics is that it helps to make some of those ideas more precise and in the language of mathematics. And mathematics gives a very powerful language to understand things with a level of precision which can then be experimentally verified and tested. And so I like that otherwise, I mean, I took some philosophy courses in Kanpur. Sometimes it would be just talk and you don't know, okay, maybe it's right, maybe it's not, who knows. Okay, it sounds convincing, but it's like word play also. Sometimes you feel at some point, I mean, I think there is a lot of important deep philosophical questions, but sometimes I'm also dissatisfied when it's just at the level of trying to make some with words and this thing. What are you really saying? So that's why I like the physics and mathematics that enabling us to say things with a lot more precision and learn about the unity of many things. That's one thing physics teaches you, that the same laws underlie so many things. The laws that govern why when I drop glass here is the same gravitational law that is governing our galaxies, our universe at large. It's the same, so that unity is there. So it's so that is very, I think, awe-inspiring and a beautiful thing to be working on and to think.
And like the thinking framework of physics, like you can even apply in real life also to understand many things.
As we discussed, all the technology flows from that. That's the power, I think, of the method of physics or science.
Okay, and so like you spent 13 years in HRI.
Yeah, Vanvas, I used to say.
Vanvas.
Because I was living in the jungle. It was a nice Vanvas, very pleasant Vanvas. In this thing, yeah.
And after that, like you guys founded ICTS.
As I said, 2015 I moved to Bangalore. At that time, my predecessor had actually gotten much of the campus constructed and many of the foundations laid. Some of the initial faculty were hired, and he was also very keen that I come. And so it resonated with me because of, again, what I said earlier. Even at HRI, one reason to move to HRI was also that it was a new institute and you could kind of shape it. You could mold it in some way so that it doesn't fall into the same traps as some of the older institutions.
Traps like?
I mean, many institutions fall into the traps where there is just either too much politicization, a lot of petty fights, and in the end losing sight of science. I mean, in the end you want to create an institution helps if it will lift everyone who is part of it to better and better heights, whereas many of our institutions, people are trying to pull everyone else down.
Because it also has administration component, like someone is admin in the campus, so Politics will be there for sure.
Yeah, no, administration is important because that is what makes the things run and allows scientists to do their work. So they have administration and the science have to work together and have a kind of meeting of a meeting of goals, meaning they should all be having the same goal. Administration is helping in its own way and playing a very important role, and scientists sometimes tend to look down on that. That is not right, I think, because administrators should be also given their respect and their dignity and that they are doing. I think many times scientists also tend to have like the superiority attitude, which I think is not very healthy. We are all trying to do our best. I think whatever we are doing, it should be valued and it should be respected. Even if you are just doing accounting in your office or you're thinking about string theory, you're all human beings. We shouldn't forget that. So at the same time, the administration should. That's why I think that meeting of minds or having common goal should be there. There should be an understanding that we are all trying to build it into a center of excellence, where excellence in terms of quality, in terms of the ideas that can be generated, and where people feel happy and feel enriched. It's not easy to create that atmosphere. It's a continuous task because so you have to carry everyone along and make everyone feel that they are part of a big or small, I don't know, but part of a collective activity that आपका भी हिस्सा बहुत ही
This is a whole ecosystem, na? Like everyone is a part of that system.
Yeah, and should feel that they are contributing and they are valued for it. They are so that I feel is an important ethos that one has to have in an institution. Very often it's not easy to manage it. It's not that only in India, everywhere in the world, it's not easy to manage that kind of thing. But in India, I think we can do it. People are much more interpersonal relations are very important, and if one can create the right interpersonal relations, I think it can be very nurturing environment also. Unlike in many other countries where things are very professional, people just come, they do their job, and go away. They'll do it very well. They'll do whatever they can to help you, but everything is within some sharply defined boundaries. Whereas in India, people will go out of their way sometimes to help you. Many of our program staff are working at night and they answer emails from visitors and other participants who come for our programs. And they come here at different very early hours, late hours. They are working out of dedication and because they feel it is good, positive thing they're contributing to. So in India, that we have that feeling amongst many people, but we have to therefore encourage that, and it can create a different kind of institution. So that was my hope coming here, and I've been trying for the last 10 years. I think
that was the idea behind this institute.
I mean, the idea, of course, the scientific idea was the bigger idea that India needs a place where people can come together, and because our Indian community is scattered along many institutions around the country, it's such a big country, also geographically diverse. And so often what happens in any particular area, one or two people in each department in many places, they're all scattered. So that critical number is not there for collaborations, for doing things, doing new things. So what we have, and this is the unique thing about ICTS, is that we have these programs and workshops, what we call programs. They are we have workshops, collaborative workshops, or even some training schools, which are aimed at PhD students and active researchers. So about half the participants are PhD students, some master's students, and half are researchers. Mm-hmm. And they come here for 2 weeks, and they are working together. They are collaborating sometimes. They are teaching each other. We have mini lecture courses. So they are basically and about new ideas that are there in science, in different areas of science right now, cutting edge topics. How do we make sure that our Indian scientists are not left behind? Our students are getting exposed to these new ideas, and at the same time they are also maybe having the opportunity to collaborate with the global scientists from around the world. So those were part of the ideas behind ICTS. There are similar institutions which have worked very well in the United States, in Europe and Japan and so on. So the thing was, in India also needs such an institution. And these are organized not only by, the academic organization is done by scientists from around the country. They send proposals that we want to organize this on this topic, this workshop here at ICTS for 2 weeks or 3 weeks. They send a proposal, and we have deadlines, and then all the proposals are scrutinized by a committee, a national committee, not only just ICTS people, so a national committee of people, and they select the most exciting, most interesting proposals, and then we support them, so that the people who organize these, they have to only take care of the academic part, who to invite, what kind of program to have. Our staff takes care of all the logistics, so all the visas and other travel arrangements, the guest house, they stay on campus here for 2 weeks. They're all together and they're working, and that leads to a lot of good science. So we have been keeping track of the number of publications coming out, and almost like a couple of publications every couple of weeks. So it's like 650 or 700 publications in the last 6-7 years come out of these workshops. So it's not a conference center. It's mainly for people to collaborate and enhance Indian science.
And in ICTS is international, so you have collaborations with premier institutes of US.
So people come from all over the world. About just to give you numbers, 3,000 people come every year to ICTS, outsiders, for all these workshops. About 800 or so have been from abroad. Typically, that's the breakup. And that's very important, because globalization of ideas is what leads to progress. Someone else does some work here, someone else picks it up. It's like a relay race. You build on other people's work, and you need that exposure. Otherwise, you will not be competitive. You will be falling behind.
So kudos to the efforts. But what is the current situation of research and academia in India? Post independence, we haven't seen much breakthrough in a very global kind of research from India.
Right.
So your take on it?
Yeah, no, I feel it is also because maybe, I think before independence, there were not many research institutes or other thing, but there were a few individuals who did, despite a lot of obstacles, they managed to do world-class work, and they were also fired by this idealism that kuch karke dikhayenge. That I feel we need more of that also now, that we should feel that confidence that we can do something. And we have now much more resources, many more people. But it's also true that not that many of the bright students go to sciences. Again, they go, like you said, for
Corporate
all of these
civil
other
services and all.
or many other things. There are many more options. Maybe pre-independence, at least a good fraction used to go into science, and science was considered very important for building the nation, and it is still important. And I think we need more people who do that. I think but the overall level has increased because of the number of institutions that are created. I think the average level has increased. The spikes that we have seen before independence, has become less. We don't see that kind of still, but there are still many important developments have happened. People from India who have made very important developments in many areas of science, but not like Bose or Satyan Bose or J.C. Bose or C.V. Raman or Ramanujan or things like that. But I think it will happen. It's now that the average has increased, you will, but you have to encourage more bright people to go into science. You have to give the infrastructure also. Modern science is also, I think earlier the handicap was a little less because it didn't require such expensive things. C.V. Raman could do his experiment with very basic equipment, J.C. Bose for that matter. But now, especially for experimentalists, the costs of equipment, or even for many theorists, the costs of computation, because people are using computational tools very much. These have become also a lot. So that handicap is also there, which we have to address. And India spends 0.6% of its GDP on science, whereas China is spending 2.5%. Okay. And US spends till recently, US used to spend 3.5% of its GDP. And these are countries whose GDP itself is much bigger. So China has maybe 3 times the GDP of India, and it is spending 4 times as much as a percentage. So that's a factor of 10 or 12. That's very difficult to also compete with, and US similarly. And the number of scientists. So these are 2 important data points, I think, that are important: the percentage of spending on science and the number of scientists also per 100,000 population. How many do we have compared to China or US?
Exactly. So I am curious to know the percentage of students pursuing academia as compared to corporate or government jobs.
It's very, I don't have the exact numbers off the top of my head, but it's, I'm sure, very small overall.
What is the reason behind that? Is it money, maybe?
Yeah, it could be money. It could be the fact that most people don't even think of science as a career. They think of science, engineering is what,
exactly,
or medicine, or then afterwards go into management, or maybe startups, or whatever other things. That's what is there in the media, and that's what I think society as a whole feels that that people should be doing. And I think if you keep money as your only marker in life, then that I think is inevitable. But I hope there will be enough people for whom money is not the most important thing, because you'll never be rich as a scientist. Mostly. But it's a question again of how much money do you need if you want to lead a good middle class existence. I think India pays its faculty that much. So I think we can. I think it's a question then of individual choices.
One can expect, or how to build career in science, if you can give some advice on that.
So I feel people should do something which they enjoy. I've seen many people who have said, in school, I enjoyed maths and physics, but somehow, because of various things, I ended up doing this. And
So
then
that was very elementary thing. Na? In school, though, there were very simple problems, but now when we look at the board and very complex problems.
that, of course, everything is a learning process. From simple things, you learn and build foundations, but it is your inside this thing that.
It's self-driven fire.
Yeah, Antaragni.
Exactly.
Like IIT Kanpur.
That cultural festival.
Yeah. So that thing, I think, is important because, of course, everyone may not find it their cup of tea afterwards. Because as I said, you have to be self-driven. It's like running a marathon. I mean, like JEE is like 100-meter dash. Scientific research is like running a marathon. I mean, so you have to have that stamina and be able to do things, be discouraged. It's an ultra marathon, I would say. It's not even like your whole life you have to be running. You have to have the stamina to keep running. And for that, you need that inside fire. For some people, maybe temporarily it may be there, but after some time it may go. That's fine. But if you feel, you should give it a try, I think. If you feel you enjoy science, nothing bad will happen if you do your undergraduate degree in science. Now there are some apart from IITs which have BS programs, there are also ICERs which have very good program. NICER in Bhubaneswar is there, CMI in mathematics and physics is there in Chennai, Center for Basic Sciences in Mumbai is there, and many other, even some of the BITS have a bachelor's program and so there are good programs in the country. IISc, Indian Institute of Science, has a very good undergraduate program in sciences, one of the best in the country. So there are many options now. And it's not like if you do any of them, like you'll be in some bad shape. You'll have good opportunities if you decide after that, okay, I don't want to do physics, I'll do other things. Even in my batch, we were 10 people who were doing the master's program in physics. But now maybe 3 of us are in academia out of 10. Others are doing good jobs, other things. Some of them have their own companies. Very good friend of mine, he has started multiple companies and he has been successful, very successful. He worked in McKinsey, he worked in many global companies, and they appreciate his physics training. That physics training proved to be very useful for him. And so you can do other things. So you don't have to, it's not like, okay, once I've done this is my single track and I have to do PhD, I have to go become a professor. Waisa nahi hai. I mean, you can branch out and do very creative things. The current director of IIM Bangalore, he's from the 5-year program in physics from IIT Kanpur.
Okay.
Yeah. So he's now the director of IIM Bangalore, Rishi Krishnan.
Okay.
So it's like that. I mean, you will see there's so many people from IIT Kanpur physics program who are doing things you will not even associate with physics, but very creative individuals doing new things.
Sir, I think the whole problem is narrative. Like for the long time, we have celebrated artists, actors, now we have started celebrating entrepreneurs, but we didn't celebrated scientists and professors that much. I think that's the problem. Like people don't have that exposure to their life and
exactly
and everything.
Yeah. No, I feel.
But I find scientists very cool.
Thank you. Yeah, I find it I find it a privilege to lead the life of a scientist. It's a very unique privilege, which makes up for many things.
Okay, sir. So that's all for today. Thank you so much for coming
thank
and
you.
giving us your time and sharing your learnings, insights, and invaluable lessons. Valuable lessons. So thank you so much.
Not at all. My pleasure.
Thank you, sir.